Good day, friends. Today I'll be talking about the data science story of Google's flu trend, a story between 2008 and 2015. The big data 2008. Around 2008, Google researchers had a bold insight. People search for flu symptoms before they go to the doctor. Google has access to billions of search queries in real time. In US Centers for Data for Disease Control and Prevention CDC by contrast reported influenza like illness ILI data with a 1 to 2 week delay. So the question was simple and seductive. Can search data predict flu outbreaks faster than traditional epidemiology? They analyzed historical CDC flu data and correlated it with millions of search terms like flu symptoms, fever and cough, muscle aches. Using automated feature selection, they identified about 45 search queries whose frequencies best match past flu activity. In 2009, Google published results in Nature. Google Flu Trends could estimate flu prevention in real time, often matching CDC data remarkably well. The data science world was dazzled. Early success and hype. For a few years, GFT Google Flu Trend looked spectacular. It tracked flu trends almost in real time. It appeared as accurate as CDC. It was based on passively collected big data, not surveys. This was peak big data optimism. With enough data, numbers speak for themselves. GFT became a poster child for newscasting, alternative data, machine learning replacing traditional models. The cracks appeared 2011 to 2013. Then the things started going wrong. The 2012-2013 flu season. Google Flu Trends dramatically overestimate flu prevalence by more than 2 times in some weeks. The CDC was seeing a bad season. GFT was seeing something apocalyptic. Why? What went wrong? The deeper story, non-stationarity, the world changed. Search behavior is not stable. Media coverage influences searches. Panic changes behavior. Google's own autocomplete and search suggestions changed query frequencies. Example, in CNN runs, if CNN runs world's flu season in a decade, healthy people start Googling flu symptoms. The model interpreted fear as illness. What went wrong? Feedback loops. Google wasn't just observing behavior, it was shaping it. Search result, autocomplete and suggestions, public awareness of flu severity, news coverages influenced by Google data. This created a reflexive system. The model changed the data generating process. Overfitting at scale. With millions of candidate features, it was easy to find queries that matched historical flu patterns by chance. The model fit historical CDC data extremely well, had limited causal grounding, was not robust to regime changes. Classic high dimensional overfitting, just as planetary scale. Non-epidemiological constraints. Traditional flu models respect constraints, transmission dynamics, population limits, seasonal structure. GFT was essentially a correlation black box with no domain theory to stop it from making absurd predictions. Ignoring gold standard. Ironically, Google tried to replace CDC rather than complement it. Later analysis showed a simple hybrid model combining CDC data plus Google searches outperformed GFT alone. But GFT was marked as a replacement, not as assistive signal. The fall 2015. By 2015, Google Flu Trends was quietly discontinued. The project wasn't a total failure. The idea of digital disease surveillance lived on. Search and mobility data are now used carefully by public health agencies. But the original vision, big data alone beats institutions, collapsed. Why data scientists still talk about it? Lesson 1. Big data is not better data. Volume cannot compensate for bias, non-stationarity, feedback effects. Correlation is fragile. High correlation in past does not imply causal relevance, stability under intervention, validity under regime shifts. Models live inside systems. If your model influences behavior, your IID identically and independently and identically distributed assumptions are gone. Domain knowledge matters. Purely data-driven models without theory are brittle in real world. Augment, don't replace. The most successful system combine mechanistic models, institutional data, machine learning signals. How it changed data science. After GFT, nowcasting became more cautious, hybrid models gained favor, epidemiology embraced machine learning but with guardrails. The myth that data speaks for itself lost credibility. Today, Google Flu Trends is taught alongside the Lucas critic in econometrics, Goodhart's law, dataset shift, and concept drift. Finally, the one-line summary. Google Flu Trends didn't fail because it used big data. It failed because it forgot that data comes from people and people react. Thank you. I'll stop here. Like, comment, share, subscribe my video. I'm available for one-to-one discussions too. Thank you.